So now we're going to look at 11.2, and we're going to look at hypothesis tests for paired data mean. So we're going to look, it's on page 39 of your packet, and we're going to look at the hypothesis difference between two means or paired data. So when we're comparing means and have paired data, we're going to do a hypothesis test on the difference in means. Okay, this hypothesis test is called a paired t-test. So you might want to add that on top. I don't have a space for that, but you might want to add, it's called a paired t-test. And for paired data, the null hypothesis, H naught, is we say mu d equals 0. That's what we do for the null. It's always mu d. And then the alternative is mu d is either less than 0, mu d is greater than 0, or mu d does not equal 0. So left-tailed, right-tailed, two-tailed. And we define mu d usually as mu1 minus mu2. And so those are the three alternatives. Okay, so for a paired t-test, our calculator procedures are the same as kind of the confidence interval. We put L1 and L2. We highlight L3, and then we do L1 minus L2 to get the differences. And we're going to run a t-test on L3. T-test. And again, the name of the test is called paired t-test, but we still run a t-test. So let's look at example 4. I have a little bit more context than they do in the packet, so that when we're answering the questions, we can explain it a little bit better. But it says a sample of 8 automobiles were run to determine their mileage in miles per gallon. And then each car was given a tune-up and run again to measure the mileage a second time. And so yours just says, using the data about a tune-up improving car engine miles, test mu d equals 0 versus mu d is greater than 0, alpha is 0.01. Now this one, they gave you the differences for you. So we don't really have to do the whole L1, L2. We could just use the differences in this case. I'll do another example where they don't give it to you. But this is paired data. I know they told us it's mu d, but if you didn't know that, it's paired data because it's the same cars. So it's dependent samples. And they gave us our null and our alternative, but usually that's how we start. We write our null and we write our alternative. They gave us that. Right, so from there, we run the test. To run the test, we are going to go to, we can just do the differences in L1 to make it simple. So we're going to put these differences in L1. So put those differences in L1. Right, and then real quick, if you had to check the conditions, N is definitely less than 30, so we would check that it's not strongly skewed and doesn't have any outliers. To do that again, we do second stat plot, plot 1, and we do the plot for the differences. So wherever you have the differences, that's your X list. Again, when you put in L1, choose the box plot with the outliers. We go to second Y equals again to get to this menu. And then we hit zoom 9 to graph it. All right, and then we check. Okay, so there's no outliers and it's not strongly skewed. So we can assume the population is approximately normal. So from there, again, the test name is called a paired t-test if they ever ask you for the name of the test, but the command is t-test. So we do t-test, we're gonna do data, and our list is L1. Just make sure that somewhere you tell me that you put this data in L1 or whatever list you put it in. Okay, so that's my L1. So we're gonna go to stat, test, t-test, okay. Data, we put our null value. So our null value for this one is always assuming the difference is 0. And we're gonna put our list as L1. And then we're gonna pick our alternative and hit calculate. And we again get our test statistic, which is T, and our p-value. Now remember, my p-value is 1.92. Anytime it's bigger than 1, I would have an E, and I need to indicate that and include that. So my T is 9.145. And my p-value, either written in scientific notation or changed out of it, is 1.92 times 10 to the negative fifth. And you can leave it like that, or if you have trouble comparing it, remember this means 0 point, we move the decimal 5 places to the left. So there's 4 zeros. And it's always a very small number when we're in scientific notation. Okay. So then we do the same process from here on. So it says, using the data about tune-up, improving car mileage, check if this is true. If the difference between these two, before and after, is greater than 0. And so we're looking at the p-value is less than alpha. And so we would reject the null. And then when we interpret it, it's the same interpretation. So since the p-value is less than 0.01, we reject the null hypothesis and conclude that, okay. So we're looking at the difference in mileage. Okay, so again, mu d in this case is mu1 minus mu2. And mu1 is the after and mu2 is the before. So we're looking at the difference in the after the tune-up minus the before. Okay, so the mean of the after minus the before. So the mileage after the tune-up is greater than the mileage before. That's what we're saying by this mu d. We're saying the difference in the mileage, so the mileage before, or sorry, after, is higher than the mileage before. And that's what we're going to talk about with our conclusion. And conclude that the mileage after the tune-up is higher than the mileage before the tune-up. And since this one didn't have a question, that's like a little bit harder to figure out. But that's what we're looking at when we're saying the conclusion. And again, we're always looking at the difference and seeing which one is higher based on that difference. And since we're rejecting, we're saying there's evidence that the difference between them is greater than 0, which means the after mileage is higher than the before. Okay, so let's look at one where we then have to like actually do all the work and write it down. So a soft drink company is conducting research to select a new design for a can. A random sample of participants has been selected. Instead of a typical taste test with 2 different sodas, they actually give each participant the same soda twice. Okay, so this is the key. They're giving the same soda twice. So that indicates that it's paired. One drink is served in a red can, the other drink is served in a blue can. The order is chosen randomly. Participants are asked to rate each drink on a scale from 1 to 10. Thus, the company wished to test if the color of the can influences the rating. The ratings were recorded for each participant, and the data are shown in the table below. Does this symbol indicate there's a difference in ratings? Use the significance level of alpha equals 0.1. Okay, so for this problem, again, we have paired data because they're using the same soda. And so we will run a paired t-test. That's the first thing you have to figure out because that determines how you write the null and the alternative. For a paired t-test, we always use mu d equals 0 for the null. We are always assuming there is no difference. And we're going to define somewhere mu d each time. And mu d we're going to say is mu1 minus mu2. And you're going to tell me that mu1 is like the average for, I'm going to say red, and mu2 is the average for blue. But you need to define your variables every time and then tell me like that difference. Then we're looking, is there a difference? That's all they said. Okay, so I don't have a direction. I'm just saying, is there a difference? And if there's a difference, the difference would not be equal to 0. Okay, that would indicate there's a difference. Okay, from there, we're going to run the test. And again, the test is a t-test that we run. And we're going to put our data in our calculator. So we're going to go to stat again, edit, anything in your list, delete. Okay, so I'm looking at red, blue. I don't really care about the rater. It's just indicating like first participant versus 16. So we're going to put red in L1. And again, you're going to tell me this somewhere on your paper, and blue in L2. Okay, I want you to write that because I'm not going to assume necessarily the first listed in L1. You don't have to do it that way. So we're going to plug in our values. And for paired data, again, I always have the same number in each list. And again, just make sure you check your list. Right. So once you have your data in L, we need to run this test on the differences. And so we're going to put the differences in L3. So again, to do that, we go all the way to the top and highlight L3. And we hit second 1 to get L1 minus second 2 to get L2. And then we hit enter and it gives me the differences. And notice in this case, some are negative and some are positive. And we're always doing list 1 minus list 2 or mu1 minus L2. So it's doing 4 minus 6 is -2, 7 minus 5 is 2. And then we do that for all the data values. We're going to run the test and we do a t-test, but we're going to run it on the differences. So for this, the mu naught is always 0 for a paired t-test. We're going to change our list to L3. So we hit second 3. We're going to keep frequency 1, select our alternative hypothesis, and hit calculate. Okay, and again, we're going to put the test statistic and the p-value. So t equals negative, and I should put data list L3, and then put about the alternative that you put. Okay, I want to see that information. All right, so -7.392. And then the p-value is 0.4711. And again, the p-value is telling me the probability of getting the results of the sample, assuming that the null is equal to 0, is there's a 47.11% chance. And that's a pretty high chance, which supports that the null is true or that we don't reject the null. And so again, we compare our p-value to alpha, and our p-value is, if we compare it to 0.1, is definitely greater than alpha, okay, because 4 is definitely greater than 1. And so we fail to reject the null. And then we're going to write our conclusion. And this one's a little bit easier than last one because they gave me information. So since the p-value is greater than 0.01, we fail to reject the null hypothesis and conclude there is not enough evidence, because we're talking about the alternative, that there is and the question was, is there a difference in the rating? So there's not enough evidence there is a difference in the rating. And that was our alternative check. Make sure it matches. Our alternative was it does not equal 0. What's its difference? Okay. So we'll practice kind of the other ones in class, but that gives you an introduction to the paired t-test.